So we're now going to do a little bit of pre-lab. So you should be under activities, stoichiometry, and percent yield. That's where this page is in your OneNote. So tomorrow we're going to be in the lab, and so today we're going to just be doing some pre-lab calculations, and you'll also be reading the procedures. And both those should be done before class tomorrow. So we're going to run through this example problem together, and hopefully this will prep you then to do the actual pre-lab calculations on the worksheet for the lab. So it says, how many grams of iron 3 oxide are formed from the reaction of 5 grams of iron metal with excess oxygen gas? So we need to write the correct chemical formula. So it says right here exactly what is combining together. And that is the, I'm trying to figure out what color to write in. Okay, white. It says that iron oxide is formed, so that's a product. Way too thick. There we go. From, then here are your reactants, iron and oxygen gas. So iron and oxygen gas, O2, right, because of Hunkelbrief. And then our product right there is iron 3 oxide. So remember, iron 3 oxide isn't this or isn't iron 3 oxide, none of that. We need to crisscross charges. So it's telling you that iron has a charge of 3 and oxide has a charge of 2. So remember, we're going to crisscross and we would get Fe2O3. So now looking at this equation, it is not balanced. So we need to balance it and put in some coefficients. So I see that I have 2 Fe, so I want 2 Fe. You can do the scoreboard though as well. And then I have oxygen that comes in 2s on this side and oxygen that comes in 3s on that side, right? So the common multiple of those is 6. So 3 times 2 would give me 6 oxygens on my reactant side. Then I would want a 2 right there, right? Because 2 times 3 will give me 6 oxygens on this side. But now I have 4 iron on the right side, so I just need to change this to a 4. Now everything is balanced. Alright, so now we're just going to do a stoichiometry setup. We're given 5 grams of iron and we are trying to get to grams of iron oxide. So we're trying to get 2 grams of this and we're given 5 grams of that one. So we'll start off with 5 grams of Fe. Remember, our first step is at molar mass. So we look up the molar mass of Fe. So the molar mass of Fe is 55.9 grams, and that's per 1 mole of Fe. Then we keep going. So now we're at the step where we use our mole ratio. We have mole of Fe here, so we need mole of Fe diagonal from it, so those units cancel. We look at our coefficient. There's the 4 in front of Fe. So remember, what we're trying to get to, we said, is this Fe2O3. So mole of Fe2O3. And then we look right there, and we have that 2 coefficient. Keep going, because we're trying to get to grams of Fe2O3. So our last step is going to be the molar mass of Fe2O3. And that is 159.8 grams. So now we're going to calculate that. So we've solved for that. Now it says if you do the reaction above and collect 6.75 grams. So it's telling you right there that that is how much you actually get in the lab. You do the experiment and that's what you actually get. That's your actual yield. What will be the percent yield? So remember, percent yield is actual over theoretical times 100. So our actual is going to go in right there for our A, over, remember we just did our theoretical up there. If you did it perfectly in the lab, you should get 7.15 grams times 100. .4% yield. So that's pretty close. It's pretty good. So now what you're going to do is you're going to read through the procedures and you're going to complete the pre-lab questions and exercises. You have 2 questions that has multiple parts to it in the pre-lab. When you are doing the calculations on the pre-lab, make sure you are showing all your work. And just to give you a little hint or a little insight, with each of the sections, so like A, B, C, D, and so forth, it's walking you through just one step of like the whole stoichiometry along grams. B. Like for example, A is just, you're just going from grams to moles of the same substance. And then in B, for question number 1, you're going from grams to moles of like the other reactant that's given to you. Then in like C, it's having you go from moles of one substance to moles of the other. So it's just breaking down this whole big process that you know of how to convert grams of a substance to grams of a different substance. So just wanted to give you that insight into question like 1, and question 2 breaks it down for you as well. But you have just those 2 questions due. It's on the front and the back of that lab. And you need to make sure that you read the procedures as well. And I will see you guys tomorrow. Good luck.